Look at this wall of numbers. For a computer, this is perfectly clear, but for a human brain, trying to find a meaningful trend in thousands of rows of raw data is nearly impossible. If you skip straight to applying a predictive model without understanding what is actually in here, you are relying on pure guesswork. That is why we rely on exploratory data analysis, or EDA. Before we build any models, we use statistics and data visualization to summarize the main characteristics of the dataset. We are looking for the hidden geometry, the repeating patterns, the clear trends, and the extreme outliers. By converting mathematical noise into clear graphical forms, we give analysts and stakeholders the exact evidence they need to make faster, more accurate business decisions. This is RStudio, the standard environment for data analysis. Top left is the code editor, where you write and save scripts. Below is the R console, where commands are executed. Top right is the workspace tracking loaded data. The bottom right renders graphical plots. Understanding this layout keeps your workspace organized. To generate these visualizations, you must know how to structure the data you feed into the system. In R, data must be structured before it can be analyzed. The simplest structure is the one-dimensional vector. We build one using specific syntax. The C function combines individual elements, and this arrow stores them into a variable, like x. Vectors follow a strict rule. Every element must be the exact same data type, whether all numbers or all text. If you need more structure, you use a matrix. A matrix expands that vector into a two-dimensional grid of rows and columns. However, it still carries that same restriction. Every entry must share a single data type. That poses a problem. Real-world datasets are messy. You rarely analyze a block of pure numbers without associated categories or labels. Because of that restriction, vectors and matrices fall short. To handle mixed data, we use the data frame. It functions essentially like an Excel spreadsheet. You can have a column of categorical text data, like student names, living right next to a column of numerical data, like their test scores. Let's test that logic. If you were importing a dataset containing patient names, their ages, and their blood types, which of these three R structures should you use? You would use a data frame. It is the only structure equipped to hold the categorical attributes, like names and blood types, alongside the numerical age values. Because of this flexibility, when you use a function like read.csv to import a file into R, the software automatically converts that dataset directly into a data frame. This table shows a typical output of descriptive statistics. Calculating measures of central tendency, standard deviation, and variance by hand across thousands of records is incredibly tedious and highly prone to arithmetic errors. Instead of doing the math manually, R relies on functions. Running the summary command on your data frame instantly generates the minimum, maximum, mean, median, and quartiles for every numeric column. You compare that with the str, or structure function, to instantly verify how R has categorized each attribute, confirming which columns are text-based factors and which are numbers. By automating these calculations, R removes the mechanical burden of doing math. The computational work is handled, so you can focus your time on what those resulting metrics actually mean. Those metrics dictate how we build our visualizations. If you want to see the distribution of a variable, you plot a histogram. If your summary stats suggest heavy outliers, you generate a box plot to pinpoint them. And if you need to analyze the relationship between two variables, you build a scatter plot. There is a strict dividing line in analytics between exploration and presentation. Exploration is the initial stage. It is often messy, consisting of basic scripts and raw plots where the analyst uncovers patterns and anomalies. Presentation is the final stage. It involves polished dashboards and clear reports, built specifically to communicate those insights to stakeholders. Mastering data analytics requires competence in both arenas. You have to know how to rigorously interrogate the raw data within RStudio, and then translate those findings into a clear, actionable visual story.